Today I will try to teach scalar and vector, especially vector. Vector is very important topic for 11th and 12th student. You will have a vector mathematics chapter, all different. In the 12th class, you will have completely a chapter in the mathematics, but basic of vector like addition, dot product, cross product. Knowledge of basic vector should be with the student to understand physics better. Okay, let's directly jump into the definition of scalar and vector. Today, actually vector and scalar, I have divided this complete vector topic into two classes. First class today I will cover definition of scalar and vector, and then vector representation, vector triangle rule of addition, and the equality of vector and sum of vector, and these are the topics this class will cover. Okay, let's directly jump into the definition of scalar and vector. Let's talk about scalar now. Scalar is that physical quantity which is completely described by a numerical value and added by according to ordinary rule of algebra. What this definition mean? Actually, I will explain. I'm explaining. Means any quantity which only requires numerical values like mass. Mass, what do we say when we go to any shop? We say I want 5 kg of rice, or 5 kg of pulses, anything. You say just 5 kg, they understand what you need not to say anything. Same way, time. If you say 1 hour, completely understand people. You do not need any other things to specify to completely describe that quantity. So the scalar is simply the physical quantity which only requires magnitude. Magnitude means numerical value to be completely described. And a scalar value, what according to ordinary rules of algebra, the summation, addition of a scalar are simple, as we are doing since childhood. Algebraic addition that we follow. If we want to do if we want to add 5 kg plus 10 kg, simply this is 50 kg. Simple algebra, nothing to worry. This is so simple. Same if you want to add time, 10 second plus 20 second, what we do? Simple algebra. This is 30 second. So that is how scalar that is what scalar is. Okay, let's now go to the vector. Especially vector is much more important. Scalar is simple also and not that much hard. So let's go to the fourth slide. That is our how can I go to the next slide? Vector. Vectors are those physical quantities which requires numerical value as well as direction, like velocity, acceleration, force, displacement, magnetic field, electric field, momentum, all these, and etc. All these quantities all these quantities, velocity, acceleration, force, displacement, magnetic field, electric field, momentum, all these quantities are vector quantity, and these are incomplete if we do not specify direction. Like velocity, if we say a particular vehicle has a velocity of 4 meter per second, you need to specify in which direction. Acceleration, force also, if you are applying some force on somebody, if you apply different direction, different phenomena, different orientation, it will move in different direction, it will move, so that it is not same thing. But in case of mass 5 kg, whenever it is kept in whichever direction and whatever it is, it will be 5 kg only. But the force, if you have 5 Newton force, if you apply from north, if, if you apply from downward, it will go up. If we apply from upward, it will go down. So force, direction of force actually matters in case of direction of force matters. So without direction, force is incomplete. If you just say 5 Newton, what for 5 Newton? In which direction? You will, next question will be, if someone asks you apply 5 Newton force, you will say, na, in which direction? In which direction I have to apply force? So force is incomplete without direction. This same as all other vector quantities are incomplete without direction. So the vector is simply the quantities, physical quantities, which requires numerical as well as direction as well. But this definition, I would say, is not complete. This definition is not complete. We will see the complete definition. As simple, like simply everybody says a vector is a physical quantity which requires numerical values as well as direction. But there are some quantities which have magnitude and direction, but they do not fall in the category of vector. Like pressure. Pressure is actually a scalar quantity. It has direction. Like pressure, you always apply pressure in perpendicular direction to the surface. Same as current has a direction of flow, but those quantity fall into the scalar quantity. So I will discuss it later. But this definition is little bit incomplete. But simply we can say that a vector uh, incomplete definition. But simply we can say that any quantities which requires magnitude as well as direction are vector quantity. Okay, let's move to another slide. Vector representation. Vector is, since it has both magnitude and direction, its representation is important. Like a scalar, simply we need to write magnitude only. You just write a numerical value and its representation is done, is for a scalar. But vector, you have direction. To show direction, you have some different method to represent it. So actually we vector is represented by arrow. This, let me draw 3-4 arrow. This and let's take one more vertical arrow. This, let's say these are all velocity vector. If we say this unit vector, let's say this is 1 meter per second. So arrow of this arrow is showing the direction of vector, and the length of this arrow is is the magnitude of this vector. So if you want to draw a vector which has 2 meter per second, I have to draw the arrow of 2 times length of arrow, 2 times. This is little bit 2 times of this length, 2 meter per second. This is, I think, 1.5 meter per second around, and this is also, I think, 1.5 meter per second. So the length of arrow shows the magnitude of that vector. Like here it is velocity vector, and the direction of arrow shows the direction of that vector. Like this is like making around 45-degree angle with the surface. This is making 0-degree, this is 90-degree, this is again 90-degree. So the arrow is showing the direction of that vector, and length of the arrow is showing uh, velocity of vector. You must say, like, if you have someone might think, if we have a velocity like 100 meter per second, 100 meter per second, so how will the 100 meter, there's like you have, even this is not 2 meter which I have drawn. So what we do, we scale. Like for unit, how much, like you have you have seen in the graph, when you draw graph, there might be a different line, but you specify in the graph what you do. You should specify one unit, how much this unit box is, how much you give it 1 meter, then three this 3 unit will be 3 meter. In such a way we do in a vector, we actually scale. Like 100, if you want to draw a 100 meter, so this much of length we will give 1 meter, we will scale this to 1 meter, this much of length. And if it draws a little bit, it will be like around 100 meter, 100 meter per second vector, velocity vector. So that is how we do scaling. So you need not to worry that I have very small copy, and how will I draw 100 meter 100 meter per second velocity vector. You need not to, you need to scale for, but you have to divide it. If you are taking this much distance, 1 meter, so you have to, according to this, you have to have 10 meter of length. Okay, this is about the velocity vector representation. And you can represent like even displacement also, even force also, like this way. I have taken the example of velocity vector. Okay, let's move to the next slide. Vector addition. Like we earlier in the previous slide, we have represented a single vector. Okay, we have what if a particle, like let's say a particle, is in a tube, a ball is in a tube. Let me need to try a little down. एक ट्यूब है, उसके अंदर एक बॉल है हमारा, एक छोटा सा बॉल है, एंड ट्यूब जो है हमारा, ट्यूब हमारा जा रहा है ऊपर with what velocity, 4 meter per second, and ball हमारा ट्यूब के अंदर horizontal, both are different thing direction, you can see. ठीक, okay. This is moving with 3 meter per second inside the tube at 3 seconds. This is at t is equal to 0 second. What will happen after 1 second? This tube in 1 second, since its velocity, इसका velocity 4 मीटर पर सेकेंड है and ball का velocity 3 मीटर पर सेकेंड, तो क्या होगा 1 सेकेंड बाद ट्यूब जो है 4 मीटर ऊपर चले जाएगा. दैट इज ये डिस्टेंस क्या हो गया इसके बीच में 4 मीटर ऊपर चले गया. एंड बॉल जो है, बॉल पहले यहाँ था हमारा. लेट्स the previous state I am showing by dotted things, dotted tube and dotted ball. This is previous at 0 second. Let me write it down at 0 second, but at t is equal to 4 second where it has reached, मतलब यहाँ से 4 मीटर ऊपर चला गया. बॉल भी जो है कि अब यहाँ पे आ गया है. See, this is complete dark color. This is right now where ball is. After 1 second, let me erase. After 1 second, ये इधर कितना गया 3 meter, means ये तो we know that this is 4 meter, this is 3 meter, and since it is 90 degree, so what will be the hypotenuse for this? 16 and 9, this is 5 meter. What this 5 meter is? Actually this is velocity. This is velocity in this direction. In this direction. Here it went in 1 second. Ball moved 3 meter, but at the same time tube moved 4 meter in upward direction, ball in the horizontal direction. So resultant velocity of this ball is what? This length is giving resultant velocity 5 meter per second. Look the distance between this the earlier position and the next position. What is the distance? 5 meter. How much time it took to go 5 meter? 1 second. 5 meter per second. What is it? That is resultant velocity. This is the basic. This is to understand how the actually vector is added. Okay. This ball is experiencing two velocities. One is by itself, it is moving 3 meter per second. That is a vector. And in the upward direction also, because tube is moving, along with tube, ball is also moving. That's why the resultant velocity of this ball becomes addition of these two velocities, and that is 5 meter per second. That is what? A resultant velocity is equal to 5 meter per second. Here to notice, you cannot directly add like in addition, vector addition. Here I am not simply adding 3 and 4 because direction is different, both are not same thing. Okay, so we cannot directly add as we like जैसा कि हम लोग स्केलर में करते थे, ऐसा हम यहाँ पे नहीं कर सकते, because यहाँ पे वैसा करेंगे तो it will be 7, but our resultant velocity, the position between earlier and the right now position, it's only 5 meter, and in 1 second it covered distance. So actually when we define displacement with the, this is actually displacement, you must have studied in 11th. This is actually displacement, and when we divide displacement upon time, it gives velocity. That is what the resultant velocity. Okay. So from this example only, we are going to draw a triangle for the resultant value. How to uh, actually get the resultant velocity triangle. Okay, so we will move to the next slide. Vector addition again. Actually, if we have two vector, let's say in earlier example only, what we had, sorry, our ball was here, and after 1 second it went there. Okay, तो ये हम इसको यदि एक ट्रायंगल बना लें, ये A B C, this is paper example only. This was 3 meter per second, this was 4 meter per second. So what is this actually? AB is a vector. AB is a vector. Actually, we represent a vector by showing arrow over the vector quantity. AB is a vector. What vector? First velocity vector. Let's say first velocity vector. And BC is second velocity vector. This is because of the second velocity vector is because of the tube movement, tube velocity actually, and AP is the ball itself velocity. Now, triangle rule of addition. Actually, earlier we did we find hypotenuse and resultant velocity. That is what I'm trying to understand, like make you understand. What do we do? Like first velocity. Oh, like in the previous slide, I forgot to say you. Like if some vector is represented like this is like AB vector, then arrow is called head, and this is called tail of vector. This is head of vector, this is tail of vector. This okay. Right now I will wrap this because I'm running out of space. So you need to understand tail and head of the vector, because I need that term right now. So first velocity vector को what I did, sorry, do we have any serial chat here? Let me try it again. No, nothing to worry. This one. Okay, so you can see the head of first vector. What we have to do for triangle vector addition, triangle rule of addition, in triangle rule of addition, what we have to do actually, head of first vector, this is first vector, this is second vector. Head of first vector should be joined with the tail of second vector, like this, and the let me draw along with you. What is saying, like I have drawn AB vector, this is AB vector, head of this vector is here, and the what BC, tail of second vector, tail of second vector must be joined with the head of first vector. This is BC. This is now the resultant vector will be, this is resultant vector will be formed by joining tail of first vector and head of second vector. Head of second vector. This is what AC, that is our resultant vector. How we formed a resultant vector? First we drawn the first vector, and then we joined the tail of second vector with the head of first vector, and lastly what we did, we to form to draw resultant vector, what we did, tail of uh, first vector joined with the head of second vector, that is AC vector. So this is what, this is the triangle rule of addition. This is the triangle rule of addition. Okay, that is AC vector is equal to AB plus VC vector, where AB is first vector, AB is first vector, BC is second vector, and AC is resultant vector. This is what the triangle rule of addition is. Okay, let's go to the next slide. Hope you understand this vector addition. Vector addition is not cannot be done by scalar addition, like algebraic, simple algebraic addition that we have been doing since since childhood. This is different. Okay, you cannot just like if you have two velocity vector 5, like earlier in the example 3 and 4, 3 meter per second first velocity vector and second velocity vector were 4 meter per second, and you cannot directly add sum those up like algebraically. You will get the wrong answer if you do so. So you have to use triangle rule of addition for the vector addition. Now we will come to, because we studied the triangle rule of addition, now we will come to हम लोग देखेंगे वेक्टर का complete definition क्या होता है. Earlier we have defined vector as a quantity, physical quantity, which is what magnitude as well as direction, but that definition is little bit incomplete, because when we define the vector in that way, not all quantities that come to that umbrella does not fall into the vector quantity, because some quantities there are some quantities which have magnitude and direction, but they do not fall in the vector quantity, but they fall into the scalar group. So let's go to have a complete definition of the vector addition. Why it is happening? कहाँ पे है? Okay. Sorry, I'm not able to go to the next slide. I hope we will be able to. This is the slide that I wanted. Vector. Now the vector definition, actually complete vector definition. Have Now we will have a complete vector definition. Vector are those physical quantities which require magnitude as well as direction and follow the triangle rule of addition. This is the complete definition for the vector. Ultimately vector will have magnitude as well as direction, but those quantity must also follow the triangle rule of addition. Like we have pressure and current, those pressure and current does not follow triangle rule of addition. That is why they do not fall into the category of vector. They are the scalar because they follow the algebraic rule of addition. That is why. So the example is same: the force, momentum, electric field, magnetic field, etc. And vectors are denoted like this. Like if we have vector AB, we have to put arrow over that. BC we have done in one example. We have to put arrow, and sometimes we do like force. In this way, like velocity vector is shown by like this. In those way we denote the vectors. Okay. We have already shared the current and pressure. They do not follow triangle rule of addition. That is why they do not fall into the category of vector. Now let's come to the equality of vector. Equality of vector. Two vectors are said to be equal for the same physical quantity. Like you cannot sorry like mass can be compared with mass only. In a scalar also you cannot add mass with the time, so it must be the same physical quantity whatever you are adding. uh, if we talk about a scalar, mass can be added with the mass only, and time can be added with the time only, speed can be added with the speed only. Same way in scalar also, two vector of same physical quantity are said to be equal if their magnitude and direction both are same. Okay. Two vector like velocity vector. Let's take AB. AB is a vector which magnitude is 2 meter per second, and again another vector, let's say CD. CD is a vector which also have 2 meter per second. Both arrow are in same length, and the direction is also same, upward. So both the vector are equal. If any one of these two, like magnitude or direction, if any one of these two vary, like next this is again a dash b dash a dash b dash vector is equal to 2 meter per second. Here again let it be, here already we have one. So these two vector, let's write that down. AP vector is equal to CD vector, equal, both are equal because they are direction upward and magnitude both are equal. But A dash B dash vector is not equal to CD vector because AB direction is like horizontal direction and CD vector direction, both have same magnitude but direction are varying now. Even if like both are unequal. Okay, let's check another example. Let me rub this, then we will see another example. These two are equal, AB and AB and CD equal. Let's say we have this again A dash B dash and magnitude is same, 2 meter per second. A dash B dash vector again CD vector not equal to A dash B dash vector because direction is different. Magnitude is same but direction is different. If we increase this, we increase the CD vector, now CD, this is EF vector whose magnitude is 3 meter per second. 3 meter per second. Again problem is these two vectors are not equal because direction is same but magnitude is different. So equality of for holding the equality, sorry let me rub this. So simply for holding equality of vector of the same physical quantity, direction and magnitude must be equal. Both direction and magnitude must be equal. Okay, I think equality of vector is not that much difficult. You must have, I hope you will understand. Okay, then next slide. Let me go to the next slide. Addition of vector. Before starting this, I need to discuss some more thing in the equality of vector. Actually, let's say two vector like this. Let's say one vector like A, B, and its magnitude 2 meter per second. We can translate because two vectors are equal when their magnitude and direction are same. So here, if this vector is here, A, B, and 2 meter per second, this is again nothing changed. This translation इसका कुछ चेंज नहीं है, मतलब ये दोनों अभी भी सेम वेक्टर हैं, इक्वल हैं क्योंकि डायरेक्शन एंड मैग्नीट्यूड सेम है. तो वी कैन ट्रांसलेट अ वेक्टर एनीवेयर बाय नॉट चेंजिंग इट डायरेक्शन एंड मैग्नीट्यूड, बाय नॉट अफेक्टिंग. मतलब यदि हम इस वेक्टर को ओरिएंटेशन, डायरेक्शन, मैग्नीट्यूड से डायरेक्शन और मैग्नीट्यूड चेंज नहीं करते हैं और कहीं भी ले जाते हैं तो वेक्टर वही सेम वेक्टर रहेगा, it will not change. Okay, same vector, there will be no change in the effect of that vector. If we translate this vector here, if the magnitude is same, nothing changed, same vector. Okay, again we can take this vector here also, a b 2 meter per second. Okay, we can translate a vector by keeping the direction and magnitude unchanged. Simply, that will not affect the vector, that will not change the vector. If we are translating vector without changing its magnitude and direction, that translation will not change the vector at all. Got that? That is simple means. Now let me erase all these things, then we will do the addition of vector. Actually, last addition of vector in that triangle loan, we have studied that if a vector b vector to be added like this, so what we did, what we had to do, the head of first vector must be here, first vector is a vector, head of first vector must be joined with the tail of second vector, and the resultant vector is the is that तब बनता था, रिजल्टेंट वेक्टर तब बनता था जब हम फर्स्ट वेक्टर के टेल को सेकंड वेक्टर के हेड से ज्वाइन करते थे तो हमारा सी वेक्टर बनता था. दिस इज इससे क्या बनता था, फिर सी वेक्टर इज व्हाट, ए वेक्टर प्लस वी वेक्टर. Okay, the length of c vector will say the magnitude of this vector, and angle, whatever angle the c vector is making with the a vector is the direction of c vector. Okay, that is how we were doing that in triangle rule of addition. Okay, we will do the same, nothing will change here again, but little bit manipulation with the vector. Okay, I will rub this. This is actually a vector plus v vector. Now I'm going to rub this. Okay, now what we have to do, let's say this is a vector. Okay, now in triangle rule of addition, what we are doing, we were joining tail of we have already no need to discuss again, that is our v vector. In this, what we are doing, we are shifting this v vector to here, because we have stated that if the vector is translated without changing magnitude and direction, the vector does not change. Okay, that is why we can translate this v vector to this point without changing the magnitude of v vector, without changing the magnitude of v vector and direction of v vector. That is how we can translate this vector to this place. Okay, so now we can I'm rubbing this because I have translated. This is now our v vector and this hasn't changed. There is no change. Okay, because we have translated, the magnitude remains same and direction remains same, and to be a vector to be same, what we have, the direction and magnitude must be same. That is same vector. So now I am going to erase this. Okay, now make a parallelogram. Now make a parallelogram. What is parallelogram actually? Opposite side should be parallel and equal. Opposite side should be parallel and equal. Mean to say, this is also a vector and this is also b vector. Okay, now This is a parallelogram. Diagonal of this parallelogram will give resultant vector. There is no difference actually. Triangle, rule of addition, and parallelogram, law of addition, there is not much difference. Just we have shifted a vector to the another, like translated the vector without changing the magnitude and direction. We haven't done anything. Actually, parallelogram, this is better. This method is better to understand because the angle between this vector, let's say theta, okay, and the angle between the resultant vector and the a vector is alpha. Okay, actually looking parameters of all these vectors becomes easy in this way. That is only the case. In parallelogram you can visualize things better, like this way. The angle between two vector is a theta, and angle between a vector and the resultant vector is alpha. Now we can drive. Let's make it perpendicular to the base vector. This is 90°. Okay, now name a, this is b vector, since this is b vector, ab, AB, and then this is C, and this is D. Okay, now we will try the formula. Actually, what we want to calculate, we want to calculate the magnitude of C vector as well as the direction of C vector with respect to A vector. तो अब हम लोग देखते हैं ट्रायंगल. One more thing, these sides are parallel because this is parallelogram. Then angles are also same, like this angle will be this theta. Okay, so now we will calculate. Let's try a triangle ABCD. This is, let's say, ADE, in triangle ADE. What we need to calculate? We need to calculate AD. Okay, so what will be the AD? AD is hypotenuse there. AD square is what will be AD square. क्या लिख सकते हैं? तो यहाँ पे AE स्क्वायर प्लस DE स्क्वायर. ओके, तो इसको और एलिबोरेट करके कैसे लिखते हैं? सिंस AB इज द सम ऑफ AB एंड BE, क्या लिख सकते हैं? AB प्लस BE का स्क्वायर प्लस DE स्क्वायर. नाउ we have to calculate AB, BE, DC. Let's we will do those calculation here because we will not we do not have, हम लोग को ज़्यादा स्पेस नहीं है यहाँ पे, तो let's do here. तो क्या करते हैं? इन ट्रायंगल BDE में क्या करेंगे हम लोग? तो अच्छा, साइन थीटा क्या होता है? साइन थीटा, 10th basic thing, साइन थीटा विल बी DE upon BD. That means what we need here? DE. तो DE will be BD sin theta. One thing came, this is what I need there. Now second thing is cos theta. What is cos theta here? Cos theta is BE upon BD. Again, what will be BE? Because I need BE there. BE is equal to BD cos theta. That is what I needed here. Okay. Let's just round it. This is okay. Now come to here again. Actually, we AD square is equal to AE. What is AE? AE is AB plus BE, and we have a B. AB is AB वेक्टर का मैग्नीट्यूड क्या है? A है, तो A प्लस A वेक्टर का मैग्नीट्यूड A and A plus BD. BD cos थीटा का स्क्वायर ये होल स्क्वायर हो जाएगा प्लस डी. डी क्या होता है? BD sin theta का square. Okay, let's go to the next page. We took 13 minutes in this page. तो कहाँ तक आ गए थे? हाँ, क्या था? AD square is equal to A square plus BD sin थीटा का स्क्वायर प्लस cos थीटा का स्क्वायर प्लस BD sin थीटा का स्क्वायर. चूंकि A square BD is what? BD is the B vector. BD is a V vector. Okay, that is why it will become B cos theta square plus B sin theta का square. After so much manipulation, you will get A square B square cos square theta plus 2AB cos theta plus B square sin square theta. Again taking A square B square cos square theta plus B square sin square theta plus 2AB cos theta. Take B square common. This will become sin square theta plus cos square theta plus 2AB cos theta. That will become A square plus B square 2AB cos theta. That is AD square. AD square means AD is equal to C is equal to A square plus B square plus 2AB cos theta का root under. This is the formula for calculating the magnitude of resultant vector. This is the formula for calculating the magnitude of resultant vector. Now we have to find the direction of resultant vector with respect to a vector. Let's go to the next slide. This is the last slide. We have calculated the magnitude. Now the direction. Actually, what we had diagram. This is a vector. This is b vector, and let's make a parallelogram. This is again parallelogram. The diagonal of this is what? C vector, that is a vector plus b vector, and this is alpha and this is theta, the angle between a and b vector, and angle between resultant and a vector is alpha. So we have to find this alpha. We have calculated the c magnitude of c vector. Now we have to calculate angle between the base vector, I mean a vector, and the resultant vector. So how we can do? We have the this is A, B, C, D, E, and this was again, since this is parallelogram, so this is again B vector, and magnitude of B vector will be B, magnitude of B vector is A, magnitude of C vector is C, and this is again theta. So we have to calculate this alpha. For calculating alpha in triangle ADE, what we can calculate? We can calculate tan alpha. Tan alpha will be DE upon AE. What is DE upon AE? Means AB plus BE. We know that DE is, what is DE? DE is B sin theta, and AB is A, since magnitude of A vector is A, and BE is B sin B cos theta. So through this formula we can calculate alpha angle. Okay, this was all about the vector. Half part completed. The next part we will like dot product, cross product, and numerical what we can say, this is all. Now you can solve the example from H.C. Verma book 2.1 and exercise question. Exercise questions 2.1 and 2.2. These question you can do now by yourself. If you need any help, you can ask anytime. Okay, thank you.